Okay, today we're going to start lesson 1.4. So I want you to put on this next page in your notebooks, I want you to title it Lesson 1.4 Notes. So the notes we're taking today, we're going to do in your notebooks. And then the next thing I want you to write is, what is the learning goal? So I want you to copy it from over here. I can solve equations in one variable that contain more than one operation. I can solve equations in one variable, just like we have been doing. Only one variable involved in them. But today we're not going to say in one step because it's going to require more than one step because they contain more than one operation. Okay, so this is our goal in lesson 1.4. This is another way to say it is solving multi-step equations, having to do more than one step of work. I'm still seeing on some papers, we're having a really hard time understanding how to keep an equation balanced. Some of you are not understanding that really if you multiply one side by something, you have to multiply the other side by something. You just have not kept it balanced. So you can't just do something to one side of the equation and say that you've kept it balanced. Okay, so when we're doing these problems down, we're going to put this little note here because I'm trying to make your life a little easier. Usually, so since we have more than one step of work to do, so write this little tip down. Usually, you should undo subtraction or addition first. You could say addition or subtraction, doesn't matter. I don't know why I said subtraction first. So usually, you should undo subtraction or addition first. Now that's really like a tip because you know what? I'm not saying you have to. It doesn't say you must undo addition or subtraction first. I'm just trying to make it a little bit easier for you, make it more friendly for you so that, and I'm going to show you what I mean by that. We're going to take the first one that we solved and we're going to do it both ways. We're going to do it this way first. So let's solve the following equation. We have a negative 4x, or negative 4, excuse me, no x involved in it. Negative 4 plus 7x equals 3. Now my tip is, says usually undo subtraction or addition first. Well, since this one is addition, we can read it backwards. We can see that we have 7x plus negative 4. What would we do first in this one then? Using the, let's undo the addition first. What should we do? Then 7x minus 4. Okay, so we could rewrite this like this, you're saying? 7x take away 4 equals 3. We could just rename it like that. Okay, we can do that. Let's do it. Okay, then, so now we haven't done any steps of solving yet. We just renamed it maybe to make it a little easier to decide what to do. What would we do now? What would be our first step of work? Alexis?
Add 4 to both sides.
Yeah, add 4 to both sides. And now we have the 7x alone, and we have a 7 on the other side, right? 3 plus 4, 7. So the subtract 4, add 4, they cancel each other out. They take care of each other. And then we have 7x equals 7. Next we would divide both sides by 7, right? Okay, so we take 7x and we divide by 7, and 7 and divide by 7. And it appears our solution is 1, right? 7 over 7 is 1. Okay, so that was pretty painless, right? So bad. Anybody have any questions about it? Any part of that right now? Okay, but I want us to see that, you know what? I don't get to make the rules. There is another way to solve this. So let's write it down again. Negative 4 plus 7x equals 3. If you don't follow the tip and you say, I'm going to undo the multiplication first, If we want to undo the multiplication, what do we have to do? We have to divide by 7. And we have to do it on both sides, right? But here's the deal. Students sometimes decide that, you know what, if you're going to divide first, or multiply first, they just divide the piece on the side that they want to divide, and then they divide the other side. But here's the deal. When, I don't know if you know this already, but just in case you don't, when you multiply or divide both sides of an equation, you have to do it to every piece. So since we're doing this first, there are 3 pieces. We can't just do it to one piece on this left side and then do it on the right side. We have to do it to every piece of the equation. So let's go ahead and do that. Let's take -4 and let's divide it by 7. Let's take 7x and divide it by 7. And our goal is to get x so that it's a 1x, so that's what this is going to accomplish, isn't it? So those 7's cancel. And now we do have that x. But let's go back here and say, how many times does 7 go into 4? Doesn't work very well, does it? No. I mean, 7's nice decimals. You know, they're not. They're repeating decimals. So we are going to leave this as a -4/7. And the other side, how about that one? What should we do with that? Change it to a decimal? What do you think? Leave it like it is, yeah. So this is a legitimate way to go about solving it also, where I'm doing the multiplication first, going against my tip saying usually you want to do it the other way. And now we say, okay, what am I going to have to do to both sides to get that x by itself? Yeah, add 4/7 to both sides. Add 4/7, add 4/7. Notice when we add or subtract, we only do it once on each side. When we multiply or divide, we have to do it to every piece. So that's why sometimes it's just a good idea to do the adding and subtracting first. You can just get that out of the way. What is 3/7 plus? These cancel each other out, right? They become 0. They're opposites. So what's 3/7 plus 4/7? 7/7, and 7/7 is 1. We got the same answer, didn't we? Which way did you like better? The first one, yeah. Isn't the first one cleaner and nicer and, just a little bit friendlier? But in reality, both ways are okay. We got the right answer both ways. It's just which way seems a little bit nicer. So that's why I made that little tip at the beginning. Usually, you want to undo the addition or subtraction first. Okay, let's go on to then, I want you to solve this one. Now that you've gotten to C1 and we worked it together, go ahead and solve this. Let's see, that's a 1.2y, and then it is subtract 5 7/10. Okay, go ahead and solve that one. Decide how you want to do it. You can use my tip or you can use your own way. I would highly suggest the other way. It's very good this time. So maybe I should write this just a little bit better to make sure you have that correct. I don't want you to. It's 1 2/10 y. Anybody have an answer yet? Y equals tricky one? Should we have a calculator? Did you all get to the point that I did right here, where you've added 5 7/10 to both sides? You have a 7 2/10 now equal to a 1 2/10 y. And then you have to divide both sides by 1 2/10. Yeah? Okay, and then these guys cancel, so we have our y alone. What happens when you divide with decimals? Anybody know what we can do to make this? Remember the rules for dividing by decimals? Well, then you're going to do it like this. You're going to say to yourself, what's $1? How many times can you take $1.20 out of $7.20? Oh, that's a finger. How many times can you take $1.20 out of $7.20? Does anybody remember doing this when you divide with decimals? Move the decimal point over 1 so it's a whole number. If you do it for that part of the division problem, you have to do it for the other part of the division problem. You got to move it the same amount. So now what we really have is 72 divided by 12. Does that help? Anybody know how many 12s there are in 72? There's 6 of them, yeah. Now I want us to just draw a line down. I want us to do it again a different way. I'm not going to do it the way that, let's undo the multiplication first, because that would be so ugly in this problem. I don't even want to go there, okay? I want us to write the equation down again. And I want us to talk about renaming that equation before we solve it. So in other words, making that equation friendlier before we solve it. Anybody think they know what we could do to rename this equation? I don't even want you to rearrange the parts. I don't want you to have anything trade places. That's not what I mean. Could we rename the parts of that equation so that it's friendlier? A hint. Could we get rid of the decimals? Anybody know how we could get rid of the decimals? Put X's to them. We move them all to the right one. And moving them all to the right one is really the same as what? Multiplying by 10. So we're multiplying every piece of the equation by 10. Remember what I said. Whenever you multiply or divide, do it to every piece. Well, as long as we do it to every piece, we can now say, well, you know what, this looks a lot friendlier without those decimals. I just seem to like it better. It's this. Solve this one. We better get the same answer, but solve it. Rename an equation before you work with it. And you can do that as long as, remember, if you multiply or divide by something, just make sure you do it to every piece. The same thing to every piece, and then you're safe. Okay. Anybody have any questions? Okay, write down the following one. We're going to solve another one, and then we're going to do one last. We'll do an application problem, and then we're going to work on homework. Solve. And not only do I want you to solve this, but before you solve it, I want you to rename it. So we just renamed that last one, and I don't want you to rename it with its decimal names, okay? I know these all three happen to be nice decimals, but that's not what I'm asking you to do. I'm not asking you to rename them as decimals. I want you to rename this problem before we even start it. Okay, what did somebody rename this as? You want to share with us, please? London.
6 8 plus 4 8 equals 7 8.
plus 4A's, but there's no A behind it, right? Okay. Yeah. Give them all the same denominator because we're gonna do some subtracting, and whenever you subtract, you have to have common denominators, don't we? So let's just rename it right away from the beginning, get it set up right away, and then we can go about solving it. So go ahead and solve this now. Now that we so nicely renamed it. I get 1/2. Anybody else get that? Person did anyway. Make me feel better. Anybody else? 1/2? I will do. So after we subtracted 4A's from both sides, because remember it's friendlier if we do that first. Then we have 6A's, A equals 3A's. And then because A is being multiplied by a fraction, we multiply by the reciprocal. The reciprocal is the 8/6, so we do that on both sides. Well, those 8's and 6's cancel each other on the left. We get A. Over here, our 8's can cancel. 3 goes into itself once, 3 goes into 6 twice. We have 1/2 as our answer. Now this would have been one that could have been, all of them could have been changed to decimals, and you could have used the decimal form, and it would have turned out to be 0.5 at the end. But this is actually, I think, easier just to leave them as fractions and give them a common denominator instead. Okay, open your books to page 35, please. And in our notes, we will put that we are on page 35, and we are going to do the check it out problem on that page, so make note of this in your notes also. We're going to do check it out problem number 4. The last thing we do together, and then you can work on there. So after you have written this much in your notes and get your book over to page 35, read the problem to yourself. If you're not reading about Sarah, you're reading the wrong problem. Here's what we're going to do with application problems from here on out. We're going to, even if they don't tell us to, we're going to write an equation, an algebraic equation to help this problem solve. Well, that means we need to put a variable in for the unknown. And before we even write our equation, we're going to say, what does that variable represent? What's it standing in for? Or in other words, what is the unknown? So anybody want to pick a variable and tell us what they think we should have it represent? What's the question in this problem? Is it something like this? How much is the monthly fee? That's the unknown, isn't it? Well, month starts with M, so I'm going to choose M since you guys just don't want to play along here. M is monthly fee. We write that down. We say, you know what? When I look at my equation, I can say to myself, M is standing in there for the monthly fee. We don't know what it is right now. Well, then they gave us some information about, like there was a membership fee, if I remember right, and there was a monthly membership cost, and they said how much money she spent altogether, and we just don't know how much it was every month. So, how many months did she do this for? 12. Okay, anybody can think they can come up? What? Everybody, why don't you try to write your own equation down right now? But you can erase it if you're wrong. Write down something you think would help us solve with a monthly fee. Sometimes I like to, and I think I did this in that word problem strategy sheet that I gave you. It's good to write out something in words that can help you then, you say to yourself, oh, well, she paid a membership fee. How many times she paid that? Well, did she pay the membership fee only once? I think, I hope so. And then she went for 12 months, but we don't know how much it was every month, right? So there's some kind of monthly cost all added up for 12 months. And then in the end, it tells us how much money she spent, right? So what's an equation we could use then? I used a word sentence here to start with, but how can I replace it with an equation? Mitchell?
$15.95 plus 12M equals $735.95.
$735.95. Yep, and we can leave our labels, by the way, like the dollar sign and stuff on our equation. Does everybody think that'll work? Look something like yours? It's not the only way to write the equation. Anybody else want to share their equation they think would be just as good? Okay, then I guess we'll solve this one. Oh. How much was it per month? That's what you're trying to figure out, the monthly fee. Well, this crazy. We're dividing by 12 again. I got 60. How many times have we taken 72 divided by 12? We feel like that. A few? We should know that one by now. Okay, but we're not going to stop here and just say that's 60. We're going to, whenever we do application word problems like this, we're going to write a sentence answer as our final answer. We're going to go back to the question and see what the question was, and we're going to answer it in a sentence. I think it said something like, how much is the monthly fee, right? Well, then we can make that pretty easy. We could say the monthly fee is $60. The monthly fee is 60. That I won't make you write out in words. $60. So we're going to start on our word problems with a variable describing the unknown. We're going to use our variable in our equation, and we'll solve that equation, and then we'll give our final answer to whatever they were asking us for in a sentence. Okay? Any questions? Hearing none, you're telling me you're ready to start practicing on your own.